Hi, filter sterilization is a physical method of sterilization. It is widely used for the sterilization of the air and for the uh, animal tissue culture and plant tissue culture. Filter sterilization is used to sterilize of free fluids, just like gases or liquids. It cannot be used for the sterilization of equipments or something things like that, but we can use it for free fluids. It removes dust and microorganisms from the fluids and gases. It is highly effective and it's also really inexpensive, and it is mostly used for the sterilization of air for fermenters. We cannot actually use it for the large scale fermentation because most of the large scale fermentation uses byproducts of some industry as the media. These byproducts will have so many particles and components. If you are using filter sterilization, if you are using a filter to sterilize the medium, it may clog and it will cause so many complications. So generally we are not using filter sterilization for the media, but we are using the filter sterilization for the sterilization of air, and it can be used for the sterilization in animal tissue culture because we are using more refined media in animal tissue culture. The thing is that it is actually really inexpensive for making the steam, transporting the steam, and having the cookers, autoclaves, and everything is expensive. But filter sterilization is relatively inexpensive. Only thing is that it cannot be used widely. And filtration is done not only by a single mechanism, it is happened by multiple mechanisms, and these are the principles of filtration, which include straining, internal impaction, diffusion, electrostatic attraction, and interception. I will just tell few words about these. First one is straining. This is what we'll do in our house when we are filtering the coffee. So we have a filter, we have a arepa, and it has some pores, and when we put coffee in that, the coffee powder has larger size than the filter, so the coffee will pass through, the coffee powder will remain in the filter. So that's training. It's a basic principle. So these lines are the filter. So all filters are made up of filter media. We call it as filter media. The material which is used to make filter is called filter media. It can be a plastic, it can be a glass, it can be a paper or cloth or ceramic, anything like that. So these lines are the filter media, and this is our medium. So when we are applying it, the larger particles cannot go. It will be retained in the filter medium, but small particles can go. So these are the filter media. These are the compounds. This compound is bigger than the particle is bigger than the pore size, so it cannot go. It will be accumulated here. So that is actually straining. Then we have internal impaction. Next principle. It's the change in flow direction and the principle of inertia to separate the particulate from the stream. So the thing is that the medium is flowing in one direction. So as the medium, maybe it's a air or liquid media, it is flowing with the particle in one direction. So the particles is also accelerated in the same direction. So what happens is that when there is a obstruction came in the form of filter, the media which is liquid, which is able to change the direction very flexibly, but the particles do not change the direction of flow or its acceleration or velocity easily. It will go still try to go straightly, even if there is a larger pore there to the particle to go, but this particle is not able to go because of the it don't change the direction of flow very easily. Here we have the video. So these are the filter medium. These particles, the small particles is able to change the direction easily, but the large particles are trapped. So you can see that the gap between the filter medium is high. This one is actually go through this place, but it won't because of the internal impaction. It is not changing the direction of the flow. It just get accumulated in the filter media. Next is diffusion. So we have something called like Brownian movement. The particles in the liquid media will move very randomly and very quickly. Because of this movement, it get trapped in some of the filter media. So that's called diffusion. So here the particles are moving here and there, so randomly moving. Because of this random movement, it will get accumulated in the filter media. So once it is attached, it won't detach. So these things are not like filtering our coffee. We are using different types of filters for utilize the property of diffusion. Those are the depth filters. You can see multiple layers of the filter media there. So even the particle miss here, it will be accumulated in the another layer. Maybe it has 100 layer. So most of the particles will be trapped. So next is electrostatic attraction. In case of electrostatic attraction, our filter media is charged. It may have a positive charge or a negative charge. So our particles may have different charge. Most of the microorganisms are negatively charged because of the plasma membrane. Plasma membrane is negatively charged, so it has an overall negative charge. If you have a media with a positive charge, the microorganism have a tendency to get attached to it. So that's electrostatic attraction. Here we can see these particles are going and they are just sticking into the filter media. It's because they are charged oppositely. So this compound is coming. When it comes, it is negatively charged, but our filter media is positively charged, so it will get attached to the filter media. So finally, we have the interception. Interception is particulate make physical contact and becoming attached to the filter media. So we are using some ceramics or something in the as a filter media. It will actually trap all the compounds. Here they are just going to stick to the filter media. Yeah, here you can see the compound, the particle gets stick into the filter media and the liquid will go. Liquid will go. So in the any filtration, we may be using one or many such uh, mechanisms to attain sterility. Uh, so for that, we are using two different types of filters. One is called absolute filters, other is called depth filters. Whenever we think about filter, we always think about absolute filter. Absolute filter, the filter you use to filter your coffee or tea is an absolute filter. In our laboratory, we are using this Wattman number one filter paper. You see the filter paper. We used to use this filter paper to filter something. In your chemistry lab, you will be using filter paper. These all are absolute filters. Absolute filters have fixed pore size. So the basically the filtration is happening because of the straining. So the particles which it has bigger size than the pore size won't pass. So those are absolute filters. These are all also called surface filters because the filtration is happening in the surface. Okay, it has the pores, so the filtration happens in the surface of the filter, so it's called surface filters. It's look like a membrane or a thin film. It's called a membrane filters. It is suitable for only very small volume, because if you're using these filters, what happens is like the particles will get accumulated in the filter. As we are using more and more time, there will have accumulation of the this particles. The particles which is filtered out will be there. So slowly it will clog the filter. The more and more medium is there will be a resistance of to move the medium from the upper container through the filter. So if we have a filter, if you are using the same filter without throwing out the particles, it will accumulate so many layers of these particles. So these particles will cause obstruction to the fluid flow. So absolute filters we can use only for the small volumes. Large volumes it is very difficult. For large volumes we are using depth filters. So depth filters are something like that. You might have seen it with the water purifier. So it has a depth. The filtration is not happening in the surface. It has a whole the whole length the filtration is happening. These filters using internal impaction, diffusion, and electrostatic attraction, etc., to get the clean filtrate. Okay, it can be made up of fiber wool, cotton, glass, or mineral slag. These are fibrous filters because it has some fibrous components in there. It is highly effective. You might have done few experiment in your childhood days, like you take some small containers or the coconut shell and you put some like coarse particles, some pebbles in one, then we'll put sand, then we'll put clay, and when we have arranged in serially, and if you have this cloudy water in the top one, it will get purified in step by step. So that's the depth filters. Because of the depth filtration, we have the clean water in our wells. So same principle is applied here. So unlike the absolute filters, we cannot say it's depth filters are 100% efficient. It has an error rate. If you are using this water filters for a long time, what happens is like it may lose its efficiency. Okay, absolute filters are has fixed pore size, so the particles which is larger in size cannot grow. But depth filters are not like that. It is more durable, it is more practical and more efficient, more effective for larger volumes. The depth filters, absolute filters are good, but it's only for small volumes. So this is how the filtration happens in surface filtration and depth filtration. In surface filtration, we have a membrane. The particles with the higher size cannot go, so it get accumulated in the surface. But in case of depth filters, what happens is like the particles are accumulated inside the filter, inside that medium. That's why we are changing the filter every 6 months for the water purifiers. So it is inside the filters. If particles are accumulated inside the filter, we actually need to change the filter or refill it. This figure show the difference between surface filtration and depth filtration. I will justly go through it. The size of particles retained is slightly higher than the mean pore size of the medium. In case of surface filters, only the particles with the smaller size can go, the larger particles cannot go. The size of particles retained is much smaller than the mean pore size. In the depth filters, even the small particles will be trapped because there are so many mechanisms are used. So many mechanisms are used to trap these particles. Maybe diffusion, maybe electrostatic attraction, internal impaction, things like that happens in the depth filters. In surface filters, mechanical strength of the medium is less, so we need to use some stainless steel, things like that to support it. But in the depth filters, mechanical strength is high. It has surface filters has low capacity. We cannot use it for higher volumes, but depth filters can be used for huge volumes. The size of the particles retained in a surface filter is predictable, but in depth filters, it is not that much predictable. All the particles can be accumulated because it is using so many different mechanisms. Equipment is expensive because the filters are so delicate, we need to support it. But in case of depth filters, equipments are cheaper. The surface filters, example cellulose membrane, Wattman number one filter paper. Then we have nylon membrane. Everything is included in surface filters. Depth filters, we have ceramic filters and the wood filters, the sand filters, etc. Then one other type of filter we are using is pre-filters. Whenever we are using a filter in the industry, the thing is that the chance of clogging is a big issue. Even if it is surface filter or a depth filter, if you are using it for a long time, what happens? The particles will get accumulated, and it can interfere the flow of liquid as well as it can damage the filter. So what we do before the main filter, we will put another filter as pre-filter. Pre-filter will actually filter out the very big particles, and the main filter will be filtering the small particles. So that's what the meaning of the pre-filter. It is just to protect and save, prevent the accumulation of the particles in the main filter. So in most of cases, the pre-filter consists of disc of asbestos or compressed paper. Okay, it filter out large particles to prevent clogging of large filters. That's they let in the fine particles. The filtration of the fine particles is done by the main filter. It actually absorbs large amount of liquid which need to be re-extracted by flushing the filter paper in regular intervals. And final filters are made up of cellulose acetate or something else. So pre-filters are essential to protect our main filters from clogging and damage. Thank you so much.